Bonjour and good morning. Welcome to WASA Distance Education Center and PLAR Geography. So we are into the 8th week of Term 1A, so that means after this week, then it'll be week 9 and the Term 1A will be over. We do have an admin week, so don't forget after October 31st, there is the first week of November. No classes for that week because that is the admin week. You can still apply for WASA courses, so students who are interested in completing their courses, or especially if you're a potential grad, make sure that you contact us at 807-737-1488, or you can connect with your local distance education coordinator. Students can sign up for IL courses anytime, so if you didn't sign up for the Zoom radio timetable or for the Term 1A, you can still sign up for IL courses. You have to finish them by June 13, 2026. So in these courses, you can contact your teacher for help, just like, if you're signed up with the radio Zoom, you can contact your teacher for help using Zoom, email, or phone. You'll have up to 10 months to complete the course, and again, the 10 months is depending on when you register. So if you register in September, then you have a lot more months than if you register in, say, May. So it's important, if you're a potential grad, that you do sign up right away. So you have a lot of time to work on your final courses. You can contact our education counselors. We have Mary and we have Michelle. They can help you choose your courses. Mary is dedicated to working with students in the PLAR program, and then Michelle looks after the grade 9 to 12 courses. Also, WASA will continue to do end-of-term draws for students. So as we're nearing the end of Term 1A, we will have a draw for Term 1A. So these are for students who submit work. So if you submit your lessons, and also if you earn a credit. So for example, if you submitted 20 lessons, then your name will be entered 20 times, and then you earn a credit. Then you will have 21 submissions for the Term 1A draw. Now, students who are in the Junior PLAR program, so if you were previously registered and you want to finish your required PLAR subjects, again, make sure you contact us. We'd be happy to register you for the 2025-26 school year so that you can complete them. And since some of you were with us last time with WASA, we've made some changes to PLAR. So if you had taken a break, you are in the Junior PLAR program, but then you didn't sign up last year or the year before, we have made changes where you can skip the lessons and take the open book test instead. So if you're interested in doing that, do not hesitate to contact us. So remember, if you are interested in Junior PLAR or in PLAR, students must turn 18 on or before August 31st of the current school year. So if you're not 18 yet, but you will be turning 18 by on or before August 31st of this school year, then you can apply, and you have to have fewer than 26 credits. Okay, but if you're 18 already, then you can apply with us for PLAR. Okay, so you remember, you have to not have, these are for students who do not have their grade 9-10 credits. So that's for the Junior PLAR. So students must have 16 grade 9-10 credits. So if you don't have 16 grade 9-10 credits, then you can apply for Junior PLAR. And if you're not sure, or if you have questions, make sure you call us. So those of you who are working on your lessons, so PLAR Geography has 2 lessons. We have key questions 1 to 13. We are now working on lesson 2 key questions, so key questions 14 to 31. All PLAR packages are the same, whether you are registered in Radio Zoom or IL, and you can continue where you left off. Again, if you decide to do the lessons instead of skipping them. we have completed up to key question 17. So if you're following along, so if you're looking at the mark sheet, so if you submit any key questions, you will receive a mark sheet that I have on the screen here. So key questions 1 to 13 is for lesson 1. Lesson 2, the key question, it begins with key question 14, so we have as far as key question 17 completed. So we're working on completing up to key question 31. And again, if you're working on these key questions and you're finding it easy, you can always let me know and I can give you the culminating activity. The culminating activity, again, you can do it even if you have already finished a lesson. This is what the mark sheet looks like. There are 3 sections. There's the section 1 for latitude and longitude, section 2 types of industries, and then section 3 there's questions about Canada's Indigenous history. So everything that you need to complete the culminating activity, it will be given to you. I think there's 13 pages in the culminating activity, so you read the information and then you answer the questions following the reading. If you require extra support, you can check out our YouTube channel. You can watch the recorded classes from this term, so 1A, and then you can also watch last year's. So if you're working ahead, for example, maybe you're working on your PLAR science already, well, the PLAR science for 24-25 is there for you to watch. So you can watch the videos, make sure you subscribe, and you can use them to support your key questions and culminating activity. So each course has its own playlist, and that will make it easy for you to find what you need. So for example, if you're working on your OLC 4.0, which is the Ontario Literacy course, so go to the playlist where it says, or go to the course under playlist where it says OLC 4.0. And if you don't have Wi-Fi or internet, you can just ask for a USB and we will download the classes there for you. When you're ready to submit your work, lots of ways to do it. You can use your iPhone Notes app where you can scan documents, and then you can email your scanned document to studentwork@nnec.on.ca, and then you can CC the teacher that's marking your work. So if it's history, geography, and science, make sure you CC it to me so that I know you have sent work to be marked. You can also take a picture, so you can use your phone's camera. Make sure you take a clear picture of your work, and you can also send that photo directly through Facebook Messenger. And then I can just view it from there and print it. So again, make sure when you take a picture, just double check. If you can't read it, that means I can't either. Okay, so just double check and then just retake the picture. You can also share it through Google Docs. So if you're working on your key questions or your culminating activity and you're just typing it in the Google document, you can click on the share button and then you can type your teacher's email. In that case, you type my email address there. So you're sharing it. There's an icon of a lock button. So once you click share, that will disappear, and then the icon will change to, and it'll show an icon of headshot there. So you can see they're like showing 2 people. So that means that it's shared with somebody else. So once you type in my email, you don't have to change the setting. If you want to keep it on editor, that means I can edit it, or you just keep it on view. As long as I can see it, that's all that matters. And then you just click send, and it will send to me, and then I will have access to your document. If you're doing it from your phone, it will look different. You will have to click on the three dots that's on the top right hand corner, and once you click on those three dots, then this menu will appear. It'll say share and export, it'll say share, link sharing, copy link, or send a copy. So choose one of those. Probably the best one is the one with the plus button that says share, and then you can do the same thing, you just send it to me. If you don't want to do that, you can have your DEC do it for you. They can scan or fax it for you. If you're visiting Sioux Lookout, or if you live around Sioux Lookout, you can drop it off at 74 Front Street. We still have the WASA outdoor mailbox. It's on the side entrance. Make sure you put your name, okay, on your work. So if you're sending in key questions or your culminating activity, make sure you put your name on it. And if you have other concerns or questions, please do not hesitate to contact me or call the office. If you're looking at the course calendar, you will notice we are on track. So this is week 8, and we are working on our physical geography. If you don't finish it for this term, you can continue on. So it's better to finish the required PLAR subjects that you need instead of not finishing the geography, and then next term you're going into, say if you needed the PLAR science, now you're working on your PLAR science. It's better to finish the subjects that you need one at a time. Okay, from our last class we looked at regions on page 4, regional diversity on page 5, landform regions also on page 5, and then we left off on Canadian Shield on page 6. So when we continue with lesson 2, we will look at the Hudson Bay lowlands, the Great Lakes, the Niagara Escarpment, Biosphere Reserve, types of rocks, to mine or not to mine. So we're going to look at different types of mining, and if we have time, we will probably be able to look at the different functional regions on page 15. On the cover of your lesson 2, you will notice that all the information that you need to get a hold of the office and to get a hold of me is on there. We also have the online link for listening to our radio station, so 91.9 FM if you're within the Sioux Lookout area, or you can go to the link if you want to listen on your computer. The Zoom link is there for my classes, the office number, the fax number, my email, my my work Facebook, and then the link to our YouTube channel. And if you have any friends or family that are interested, the WASA registration link is there as well. Okay, for learning goals, keep this in mind while we're going through this lesson. I can describe methods of mining used in Canada, and I can explain the significance of climate change and its effects on humans and the environment. Okay, let's look at quick recap from our last class. We said that Canada is a vast country and it has different types of regions, and it is based on climate, culture, and landforms. So for climate, Canada has different climate zones, and that's because of its size and location. So some major ones include northern Canada, so you're looking at Yukon, Northwest Territories, Nunavut, very cold with long winters and short summers. Central Canada, we have Ontario, Quebec, Manitoba, where we have cold winters and cool summers with large forested areas. The prairie provinces like Alberta, Saskatchewan, and Manitoba, dry climate with hot summers and cold winters. For coastal regions, so British Columbia, Newfoundland and Labrador, Nova Scotia, New Brunswick, and PEI, they have mild and wet due to ocean's influence. That's why they're called coastal. In southern Ontario and southern Quebec, they have moderate temperatures with warm summers and cold winters. For cultural regions, we have different areas of Canada having unique cultures based on language, traditions, and history. Some examples, French Canada, mainly in Quebec, where French is the dominant language and culture. Indigenous territories, so many First Nations, Métis, and Inuit communities with unique traditions and languages. Atlantic Canada is known for fishing, Celtic music, and strong maritime traditions. And Western Canada, we have a mix of Indigenous, European, and Asian influences with a strong farming and oil industry. And then the last section we looked at on Thursday, landform regions. Canada has diverse physical landscapes, so it's been shaped by glaciers, rivers, and plate movements, and some major ones include Canadian Shield. So the Canadian Shield covers nearly half of Canada, and it includes Ontario, Quebec, Manitoba, Saskatchewan, Alberta, Northwest Territories, and Nunavut. It has many lakes and rivers, and that's formed by glaciers. It's rich in minerals like gold, copper, and nickel, making it important for mining. So the Canadian Shield, so you can see it's right here. Then we have the St. Lawrence lowlands and the Hudson Bay lowlands. So we're going to look at those two next. Okay, we just looked at that word, or came across the word glaciers. So we said that Ontario's landscape was shaped by glaciers during the Ice Age. Glaciers are huge, slow-moving masses of ice, so they form in areas where snow builds up over many years and then it gets compacted into ice. So as glaciers advanced and retreated, what happened then is they carved valleys and became lakes, and then they left behind soil deposits that formed hills and ridges. Now, what makes glaciers unique is their ability to move. So due to its size, glaciers flow like very slow rivers. Now, some glaciers are as small as football fields, while others grow to be dozens or even hundreds of kilometers long. The Columbia Ice Field is the largest ice field in the Rocky Mountains. It's located in the Canadian Rockies, astride the Continental Divide along the border of British Columbia and Alberta. So the ice field lies partly in the northwestern tip of Banff National Park and partly in the southern end of Jasper National Park. Okay, let's look at no, we won't look at the key questions yet. Well, actually we can, because we covered that already. So for the key questions 18 and 19, these can be found at the end of your lesson, pages 51 and 52. So let's go there. So remember, when you're doing your key questions, make sure that you're only using the information that's been given to you, and you can only send me pages 51 to 58 when you're sending in your lessons 1 to 2 for marking. Okay, do not return the other pages because I don't need them. So we did key question 17, like I said. Why do you think Canada has so many climates? And you can start off with, I think Canada has so many climates. You tell me why. Key question 18. Why can the Canadian Shield be considered Canada's storehouse of metallic minerals? So remember, when you're looking for your answer, this one has quotation marks around storehouse of metallic minerals. So if you're reading page 6, you will notice it will say the region is a rich mineral storehouse and produces, among other metals, much of Canada's copper, lead, nickel, zinc, and uranium. Okay, that's why that's in quotation. It's a storehouse of metallic minerals. So the next key question after key question 18 is key question 19. It says, how are glaciers, which we just looked at, responsible for land formations? So you can start off with saying glaciers are responsible for land formations because, and then you put in the rest of the information there to answer the question. Okay, again, you can go to page 6. And some of the words are bolded. That means they're darker than the other words. So make sure that you look at that, because it's a key, or it gives you a clue in answering the questions. Okay, up next. Okay, what are escarpments? So escarpments, or cliffs, are common in Ontario, and they show the transition between different rock layers. Escarpments can form from faults, which are cracks in the Earth's surface. In some cases, thrust faults push land up, raising it above the surrounding area. Strike-slip faults can move pieces of land, placing higher ground next to lower ground. So specifically, we're going to look at the Niagara Escarpment. Okay, up next. Well, I think I mixed these up. So the Hudson Bay lowlands. Okay, that's supposed to be after Canadian Shield, so we're working our way back here. So Hudson Bay lowlands, these are a large wetland area between the Canadian Shield and the southern shores of Hudson Bay and James Bay. Most of the Hudson Bay lowlands are in Ontario, with smaller parts in Manitoba and Quebec. Many wide, slow-moving rivers flow through this region into Hudson Bay. Major rivers include the Churchill, Nelson, and Hayes in Manitoba, the Severn, Winnisk, Equan, Attawapiskat, and Albany in Ontario, and the Harricana, Rupert, and Eastmain in Quebec. So this was once part of Hudson Bay and are known as one of the flattest parts of Canada. It was created over long periods of time, and as the glaciers from the Ice Age slowly melted away, then the level of the land got higher. The land is near sea level, and it is marshy, and water does not drain away. Largest area of wetlands in the world, and wetlands are lands that are covered with water all or almost all of the time. It does have permafrost, which means that the ground stays frozen all year round. Only the surface of the ground thaws in the summer, and permafrost is another reason why the water doesn't not drain away easily. And in this area, winters are long and cold, and summers are short and warm. Okay, the Great Lakes and St. Lawrence lowlands. So in this small region, 50% of Canadians live, and 70% of Canada's manufactured goods are produced. The Great Lakes cause the hot, humid weather in the summer by providing the moisture in the air. So moisture in the air is also known as precipitation. The St. Lawrence lowlands is the closest region in Canada to the equator, making the weather mild. So 100 centimeters of rain each year from the humidity in the summer. Winter is unpredictable. So winters can turn out to be cold with sticky snow because of the humidity from the Great Lakes. Cold Arctic air interacts with the warm Gulf masses, which can result with it's very unstable, which means lots of precipitation for this region. Up to 80 centimeters of snow each winter, and temperatures can drop to minus 30 degrees. This unpredictability is caused by the landforms and the ocean. Okay, now we can talk about the escarpments. Let me just put that. There. Okay. Ontario's Niagara Escarpment stretches over 700 kilometers from Queenston on the Niagara River to Tobermory on the Bruce Peninsula. So the bedrock of the escarpment was formed over 450 million years ago during the Silurian period. So you can see there's Lake Ontario, there's Lake Huron, and there's Lake Michigan, but you can see where the escarpment is. So over the past 250 million years, sediment and erosion, so erosion is the wearing away of land, shaped this complex landform. So unlike many cliffs, the escarpment is not a geological fault. Okay, it is a cuesta, and that just means it has a gentle slope on one side and a steep slope on the other. Ancient oceans eroded the soft shale at the base faster than the hard dolomite and limestone on top, which created an overhanging layer. So eventually this overhang broke away, forming the cliff's slope. So you can see there on the bottom of the screen. So over time, so notice how over time wind, rain, okay, and just all the other elements eventually broke it off, and you can see how it's how the shape has changed over time. So about 25,000 years ago, the glaciers changed the Niagara Escarpment by covering it with thick ice that scraped the bedrock. When the ice melted, it left behind sand, gravel, and big rocks. Now, big rocks are called erratics. Around 13,000 years ago, after the glaciers retreated, plants and animals began to live there. So the cliffs and special soil created unique environments and microclimates, making it a good place for rare ferns and orchids to grow. Soon after, indigenous people began living in the area, using the resources the escarpment provided. European settlement started to grow in the 1800s, and then it brought more changes to the escarpment. So changes like, or activities like logging and aggregate extraction, this helped boost Ontario's economy. The same forces that shaped the escarpment also made the land good for farming, such as growing soft fruits in Niagara and apples in the Beaver Valley and Meaford areas. You can check out ontariotenderfruit.ca if you want to see some of the fruits that's grown in the area. Okay, the Niagara Escarpment is a long, steep slope or cliff that stretches from New York State through Ontario and into Wisconsin. It was formed over millions of years as different types of rock layers eroded at different speeds. The harder rock on top, called dolomite, protects the softer rock underneath from wearing away quickly. One of the most famous features of the Niagara Escarpment is Niagara Falls, where the water has carved out a deep gorge over time. So the escarpment is also home to many forests, waterfalls, and unique plants and animals. Because of its natural beauty and importance, it has been protected as a UNESCO Biosphere Reserve to help keep it safe for the future. Okay, so you can see on the right hand side of the screen, let's just move this out of the way here. The goal of the Biosphere Reserve is to achieve a balance between protection of significant ecosystem and development. So you can see here that it has three main zones. It has the core area, which is designed to protect streams, valley, forest, wetlands. So that's the most protected part. This is where natural features like valleys, wetlands, and heritage sites are preserved. So if you look on the right-hand side, the core area is the green part here. So it's right in the middle. That's the most protected. Then you have the buffer zone, and the buffer zone, this surrounds the core area where activities that support conservation are allowed. So the buffer zone is in dark blue. And in the buffer zone, you have research and educational activities are encouraged. And then the third one is transitional zone. So landowners work together for proper resource management and development. So that's the light blue area on the top picture here. So if you want to break it down, in the buffer zone, you can have tourism happening there. In the core area, you have education and training and research. Human settlement is in the transition area. So human activity is an important part of a biosphere reserve. Now, the UNESCO designation doesn't have legal power. However, in Ontario, the Niagara Escarpment is protected by the Niagara Escarpment Commission, along with local governments, organizations, and private citizens who help manage and protect this important ecosystem. Okay, the Niagara Escarpment provides ideal conditions, we said this earlier, for growing fruit and grapes. The Niagara region is one of the most productive fruit-growing areas in the world. The Niagara Peninsula between the escarpment and Lake Ontario grows most of Ontario's tender fruits. So 94% of Ontario grapes come from the Niagara region, 90% of peaches, 80% of plums, 75% of sweet cherries, 72% of pears, and 60% of sour cherries. Okay, and you can check out these links on your own. Canada's Biosphere Regions. So this is in your book. You can go to the link. The Giant's Rib, Niagara Escarpments, UNESCO World Biosphere Reserve. You can check out that link as well. Okay, when you turn to page 10, you'll come across support question number 1. Remember, the answers are provided for you for the support questions, but if you want to try these out, number 1 says name 3 of Canada's different regions. Number 2, what is an escarpment? Include a description of how it could be formed. And then 3, give 2 causes for the erosion of the Niagara Escarpment. So remember, these are just for practice, and the answers are at the end of this lesson, so you don't have to submit these for marking. Okay, we can go ahead and do key questions 19 to 20 on pages 51 and 52. We already did 19. How are glaciers responsible for land formation? So key question 20, explain the concept of biosphere reserve. So first you want to tell me, what does biosphere reserve means? And I see quite often that people forget to explain that part. So make sure you do so that you get your full marks. So there's 6 marks given there for this question. And then name each of the 3 zones in a biosphere reserve. So then you would just list them out and then give a brief description. So the first one is the core area. Next is the buffer zone. Okay, and then you can write out the third one. But remember to give a brief description. Okay, up next, types of rocks. So on page 11. So rocks are made of 2 or more minerals. Now, while minerals themselves are not made up of rocks, okay, you have to remember that, a mineral is a naturally occurring, pure, non-living substance found in rocks. So there are about 3,000 known minerals on Earth, each with unique properties. Okay, the first type of rock is igneous rock. So this type forms from cooled and solidified molten rock called magma or lava. So if the magma cools slowly underground, it creates intrusive igneous rock like granite. Now if it cools quickly on the Earth's surface, it forms extrusive igneous rock like basalt. So here's some examples of igneous rocks. There's a pegmatite and diorite, obsidian, so those are different types of igneous rocks. Next type of rock is a sedimentary rock. Now these rocks are formed from the accumulation and compression of mineral and organic particles, and often in layers. So over time, sediments like sand, clay, and fossils, they build up and then they harden into rocks such as sandstone, limestone, and shale. So other examples, gypsum, sandstone, conglomerate, okay, dolomite, these are all sedimentary rocks. So you can see here at the bottom of the lakes and oceans where sediments are deposited, the weight of the added layers squeezes particles together. So you get sedimentary rocks. Okay, metamorphic rocks. This type of rock is created when existing rocks, so if you have igneous, sedimentary, or other metamorphic rocks, they are subjected to heat, pressure, or chemically active fluids over long periods. So this process alters the original rock mineral composition and structure. So an example includes marble. They're formed from limestone. Okay, other types. There's slate, okay, quartzite, phyllite, or phyllite. So understanding these types of rocks helps us learn about Earth's processes and the materials that make up our planet. Okay, let's move on to mine or not to mine. That's the heading. So we're talking about mining. So after a mineral deposit is found, a mining company has to decide if it's worth mining. An ore body is a mineral deposit that can be extracted for a profit. So no company will invest 100 million in a mine if it won't make money. So other important factors are considered. So these are some of the factors that they consider. First one is quality of the resource. So geologists need to study the mineral deposit to find out its size, depth, and the quality of the minerals. Okay, the second consideration is projections. So this information will help them estimate how much valuable mineral can be extracted, so taken out of how long the mine can operate, and the cost and methods needed for mining. And then their third consideration is the decision to mine. So based on these factors, the mining company may decide that the deposit is not worth mining. And number four, buried deposits. So many mineral ore deposits in Canada stay buried because they are not profitable to mine. So for example, this one here, the Kami project property lies on the Quebec-Labrador provincial border. Alderon Ore Corporation jumped 7% to $1.35 after receiving final go-ahead for its Kami project from the province of Newfoundland and Labrador. Okay, so that one they went ahead with that one. Okay, demand and value. Companies also need to look at current and future demand for a mineral and how much it is worth in global markets. For example, at the start of March 1988, the price of nickel was $11,000 per ton, but by the end of the month, it increased to $22,500 per ton. Also, impact on mining. This price rise encouraged the International Nickel Company to reopen one mine and start developing another. Okay, another thing to consider is transportation. So new mine sites are often in remote areas that are hard to reach. So accessing equipment, there needs to be a way to bring in the equipment needed to start and run the mine, as well as to transport the minerals to market. Building roads or railways. So it might be a requirement to build roads or railways through rough terrain, which can be very costly. Here's an example. The high cost of building railways in the interior of British Columbia has slowed down mineral development in that region. Here's an example of Musselwhite. This is an operation located approximately 500 kilometers north of Thunder Bay. Its ore is mined from two main zones and is processed on site using a circuit that includes crushing, grinding, leaching by cyanidation, carbon in pulp recovery, and electrowinning. Gold recoveries are 96%. Labor force, well, a mine needs workers to operate, so that's very important to consideration. Many new mines are in remote areas with few towns, so this might mean that a new town has to be built. Other concerns, mining companies also face other important questions like, is there a nearby power source? Is there enough clean water available? What environmental problems could happen? How will government taxes and support affect the project? And how will the company pay for the new mine? Okay, so how does it work? Well, from ore to metal, usually the ore taken from the earth doesn't have enough valuable minerals to be used right away. So for processing needs, this is especially true for metallic ores, which often need more processing than other types of minerals. There's also low mineral content. Most metallic ores contain only a small percentage of valuable minerals, with the rest being waste. Here's an example. The nickel ores in the Sudbury region are about 96% waste. Most gold ores contain less than 6 grams of gold for every ton of ore. So if you have a gold ore, that means it's a rock basically with gold in it. Iron, rock with iron in it, and copper. Yeah, you guessed it, it'd be a rock with copper in it. So a rock that contains enough metal or metal compounds so that it can be mined profitably. Mineral recovery processes. Well, there are several methods have been created to extract minerals in a way that makes a profit. Milling the ore. First, the ore is crushed and ground into tiny particles, similar in size to grains of sand. And then they have separation methods where, depending on the properties of the valuable minerals, the ore may be washed, could be sorted, passed over a magnetic field, and treated with chemicals. So the final result after these processes, the valuable minerals are collected in a form called concentrate, and the waste material are known as tailings, and these are disposed of. Okay, so that's the waste material. When it comes to mining, they are known as tailings. Okay, let's look at different types of mining. The first one is strip mining. So this method is used to extract minerals like coal and oil sands that are found in horizontal layers near the Earth's surface. So strip mining happens in 4 steps. The first step is that they remove overburden. So the top layer, that will include trees, dirt, and rock. So all that stuff is removed. Then it's blasted. So sometimes blasting is needed to access certain mineral deposits. Then you load the material. So the mine material is loaded onto trucks or conveyor belts, and they use shovels or drag lines. And then transport material. So finally the material is taken to a storage area for shipment to markets or for processing. Now, as of October 2025, there are no active strip mining operations in northwestern Ontario. However, the region's mining activities are primarily focused on underground mining and exploration for critical minerals such as gold, lithium, and copper. There are places that they have strip mining in Ontario. An example would be Detour Lake Mine. The location of that is approximately 185 kilometers northeast of Cochrane, Ontario. The operator is Detour Gold, and the status is active open pit mining operation. So the Detour Lake Mine is one of the largest gold mines in Canada, and it employs open pit mining methods to extract gold from the site. The mine is expected to continue operating until at least 2035. Okay, so there's no open pit mining in northwestern Ontario, but there still are open pit minings in Ontario. Sorry, strip mining. Open pit mining. Okay. So open pit mining, this method is used to extract minerals that are close to the surface but may go deep into the earth. And open pit mining also happens in 4 steps. First is removing the overburden. So the top layer, again, trees, dirt, rock, all those stuff is removed. Then they drill holes. So holes are drilled 10 to 15 meters deep and filled with explosives to blast the rock apart. Then they load the ore. So the broken ore is loaded into large trucks that carry between 90 to 250 tons of ore using huge shovels. Then they transport the ore and it's taken to storage site near the mill for processing. Here's an example. The Musselwhite Mine is one of the largest gold mines in Canada and the world, and it is located in Ontario, which I said earlier. The mine has been operational for over 28 years and has produced more than 6 million ounces of gold to date. So there's a picture there of Musselwhite Mine. Another example of open pit mining, Cote Gold Mine in northeastern Ontario, approximately 125 kilometers southwest of Timmins. Spring Pole Gold Project, this is approximately 110 kilometers northeast of Red Lake. There's the Greenstone Gold Mine, that's near Geraldton. Okay, so those are examples of places where open pit mining is happening. Okay, we're going to stop here and then we'll